Anisotropic, so their work actually disabling it's blurred, setting it to the max. I don't see the MSAA. Oh, yeah, I see it here. Okay, this is perfect. No MSAA, 2 MSAA, okay, 4 MSAA, 8 MSAA. Okay, so no, from no MSAA. No, fuck it. I fucked it up. Oh no, I'm stupid. I'm too stupid. Oh my god. Oh, here. Right here. No MSAA. 2 MSAA. Yeah, it's smoothed. 4x MSAA, I can see the difference. 8x, I can see the difference. But from no MSAA to actually having MSAA, yes, I can see the difference. And if I resize, the MSAA sample count is 8. Okay. If I resize, the MSAA sample count is 4. Yes. If I resize, the MSAA sample count is 2. Correct. And here, if I resize again, the MSAA sample count is 1. Okay, so it makes sense. right here. No MSAA, 2x MSAA, 4x MSAA. Oh yeah, I can see the difference. You probably can't see it, but I do. Okay. Let's change it to white temporarily. Okay. Now I can't seem. Let's switch back to the gray floor. Maybe. Oh, yes, we can clearly see it. Here. 2x, yes. 4x, even smoother. 8x, can see the difference, but from no MSAA to 8x MSAA, I can clearly see the difference. Okay, so it's working. Like, behavior preserved. MSAA sample count 8. Okay, fantastic. I change to no MSAA. I resize. The MSAA sample count is 1. Fantastic. Okay. Beautiful. So we can remove the GFX class. Let's try to compile again. Nothing really happened, so beautiful. Okay, fantastic. So implement better graphics settings management, settings MSA, and okay, now just like 40 minutes to do a simple rework. Beautiful, beautiful. Now, what do we do? We should probably implement like the feature of the day, even though I don't know whether or not we actually like could actually implement it, like finish it today, is lighting. Should do lighting. Now we are doing a real-time tactics game, so an RTT game. So obviously ambient lighting, very basic, and directional lighting. These are the two sorts of lighting that we obviously need. Then I should probably implement something like point lights or spotlights. I don't know. I don't think we need area lights since I'm doing something like low res, low fidelity. Simply because I don't have the art skills to push assets that are actually nice to look at. And also because I want to push a lot of units on screen, so it would be unnecessary to make them high res. Like, it would be very, it would take a lot of effort for very little gameplay value, for I think no gameplay value. Okay, unless you want to do something like unless we do something like Total War, where you can basically like view the scene by the perspective of the single units, and something like that, but I'm not gonna do it, so I don't really need a very good looking art. Like near from a close perspective. What I want instead is to have a general look of something acceptable. Okay, something acceptable. So we need lighting, very simple. As of right now, we have this unlit pixel shader. What we want is simply, add a new pixel shader and call it lit. Okay. The idea is that we basically copy everything, albedo and the sampler. Okay. And okay, float 4, call I don't know why, like I know why I do it, but it's unnecessary here. Now, just to test it out, the properties. So what we do with our shaders is actually smart. It's actually stupid, but it works incredibly well. And is that we compile our shaders and output a header file containing the bytecode of our shaders. So we basically, and then we include this header file into our C++ source files. So we don't really need to load shaders because they are written in a static part of the memory of the program. So it's very nice. Output files. Output files here. Delete. This is the variable name of our bytecode. Apply. And we need to do yeah, instead of can't I simply do this, and when I do this, what? I fucked. Object file name, no object file name, header file name. Bro, come on, wake up. So I don't have to change again and again the same thing over and over again. Compile. Including project. We have generated this lit-debug.h header file, and here we see the bytecode. Beautiful. It's like 2000 lines. So. And we see the variable name, pixel shader lit bytecode. Fantastic. Okay, now we go into our renderer. Here we obviously have a debug and also a release build of our shaders. Here is the release thingy. 100 lines, fantastic. Unlit debug, I would call it lit debug, and unlit release, well, I would call it lit release. Now, just to test things out, yes, it is way faster. Huh? We still have to fix this bug. Anyway, let's go back to the bug. Okay, now the idea is that we have here a pixel shader unlit. Well, now we have a pixel shader lit also. Load pixel shader from bytecode mdevice mps lit bytecode, and this is the one in here. Lit bytecode. Beautiful. So if we do, nothing happens. Everything looks cool. Now here somewhere right here I use unlit. Why not use lit? If I use a lit, everything basically it's just the red channel of everything. Quite ugly, if you ask me. Yeah, I can clearly see the jaggies. Okay. Yeah. Okay, so we need light, so it works. That's what I wanted to do. Now we need to like we need to define two. Why two? We could use one, because you always need yeah. So here we have different constant buffers for the camera, for the object. Here we just add a new constant buffer. So vertex shader, header file, CB stands for constant buffer, ambient and ambient directional. And this will be, if the camera is the 0, the object is the 1, the ambient directional is the 2. So constant like the register, okay. So constant buffer ambient directional, and the struct we need an ambient color, and we need what? A directional light color, and obviously a directional light so an ambient color, a light color, and a light direction, basically, where the direction is from light like direction. Obviously you should think of it as from the origin of the light towards like the direction of the light, basically, towards like it's the direction of the light, okay, not the opposite of the direction, from point to light. Fantastic. And I think well, no, constant buffer that's too long and it pisses me off, you know. You know what? Let's call it lighting. Very concise. I don't like long names. I know the longer the better. No, it's not true, but like if it's too long, that's annoying to type. You know it's a bad name. So see constant buffer lighting, CB lighting, ambient color, light direction. Perfect. Fantastic. Oh, yes. Okay, I hope this is clear enough. Now we need its counterpart here. We could do some shenanigan, like copy pasting, like including an HLSLI. So include basically defining this somewhere, and in an HLSLI file, and then including this in this HLSLI, and including the same thing here, and then doing a define, replacing this float for with a vector. But I mean, like it's janky. I don't know. What's the problem? What's the deal with you? Why? Oh, because it's vector 4. Okay. Yeah, makes sense. Makes sense. I always use vector 3 and I forgot that I actually have to say. So camera constants, object constants, obviously. Oops. Oh my. Ambient and here we do this. So buffer desk, constant buffer lighting. The usage is dynamic, the binding is a constant buffer, CPU access, of course, device, desk, constant buffer lighting, and it's not there. Lighting, fantastic. And then constant buffers 2. Okay. I could. We are in C++. Why don't we use the good things? That C++ gives us. Oh, I was already fucking things up. Mind you. Like, mind you. The less repeated code you have, the better. the m constant buffers, okay, and then you simply say okay, later here dot and place back this and place back this. Very easy. We basically remove the dependency on the index. Some OP guy would say. Dot get what? Oh, the data. Yeah, it's the same thing. Like, give me the things I want. So we have like we created the buffer, our lighting, and we bind. Oh, we don't. Oh. The number of buffers dot count. No, size. Obviously, people will complain. People meaning the compiler. And I say, okay, very cool. We bind our constant buffers for the vertex shader stage and for the pixel shader stage. I know. We could use different buffers for different, like the lighting is useless here. Why not here? And I say yes, but not right now. Like yes, but not right now. Okay, everything is cool, fantastic. Now the idea is that okay, we need lighting, and right now there is no lighting, bruh. What's happening? So the color here is basically black at this point. Everything will be black. Beautiful, no lighting, just darkness, my favorite. Now the idea is that when we render, like we set the camera, we need to set the we need to update our constant buffer. So set lighting, and the idea is that we pass a vector3 ambient vector3 and here ambient color. Okay, looks good. Yes sir, looks good. Now I thought about something like the new frame returns a struct that has these things, like we could do something funky, but sorry. So, well, whatever, I mean, I don't care. Select the lighting, and here we basically do something like this. Obviously, you should remember to set the lighting before rendering. There should be something like that. So the subresource mapping, the context is cool. The constant buffer is the lighting. What's this? Subresource index, the map type, map wrap discard, the constant. This is a constant buffer. Oops, lighting. And here, obviously, we constant tuck. Can't I do this? No? This is beyond the stupid. This is beyond the stupid. But we do it regardless because it's cool. Dot x, my friend, y, z 1.0 f. Beautiful. What? Are you insane? Well, whatever. X, Y, Z, and this is 0 though, because this is like we're doing what everything does, what everyone does, and that's simply having homogeneous coordinates. And for all intents and purposes, you just really need to remember one thing. 1 at the W component, this is a point. 0 at the W component, this is a direction. Meaning, you can translate points, you can't translate directions. That's it. You can move points. You can't move a direction. If this direction, like, it's basically, because with these things we mean points, and with these we mean directions, and then you can use both directions and points. If you transform a vector, homogeneous coordinates vector, using a translation matrix, if it is a point, then it is actually moved. If it is instead a direction, the translation does nothing. Okay. So, okay, we upload the thing. When this goes out of scope, we build it, we map, goes out of scope, it unmaps. The beauty of C++, yes. Writing code that is very, very hard to read. Now, cool, everything is still black. There are multiple reasons. Let's start by the simplest one, which is, we set it to black. So, here is our constant buffer writing, and here is the constant buffer by the IntelliSense ambient color. So if we were to do this, everything would still be black. What? Are you crazy? Why? Why? What is happening? What is happening? Does it default to 1? Graphics. Start graphics debugging. Yes, sir. Can you see? Okay, fantastic. How can I capture a frame? I don't remember. F12. No. F11. Oh, yeah, here. Capture a frame. Beautiful. Stop the collection of data. What? Are you crazy? You can easily see that I don't use it. I don't use this thing very often, but it's cool. Alt F5. But it's cool. So capture a frame. Let's inspect the frame. Let's select a pixel. What? Select the pixel. This cool draw indexed. This triangle here. Let's replay the pixel shader. This is sorcery, basically. At this point, this is beautiful. Here, you can't do this shit with RenderDoc though. So let's ambient color is 20,000. Light color, no. Why? Why is it 20? Are you sure? Are you really sure? $20. What? Why? Why is it 20? This is very strange. This should not be happening. What I was expecting was close, fuck off, go away, don't save it. Questa buffer lighting, it's B2, B0, B1, B2 makes a lot of sense. Lit del albedo, the sampler, the ambient color. Allow me to just see the ambient color. Yeah, there's something funky going on. There is something funky going on. Because we never set the lighting. Never set the lighting. We never set it. This really bothers me. Oh. Let's ask. So they are not automatically zero initialized. But the freaky thing is that the freaky thing. Oh, sorry. You did not see render doc. Ah. So I capture the frame. I go to the pipeline state, the pixel shader. I see the constant buffer lighting. I go to the contents and I see this. And I'm puzzled because it's red. This. What's happening? It looks like the identity the upper 3x3 identity matrix. What's going on? It's strange honestly, but I mean, if the could be anything, so okay. Anyway, lit. Okay. Now, when we do the render, the new frame. No. Here, the new frame. We set the camera. So it's mrenderer.set lighting. Let's say ambient color. It's something like 0.1, 0.1. The light direction is something x. So it's the x, the y, and the z. So the y should be go down. So -1. And probably -1. It's not normalized. So we should probably normalize it later. The light color vector 3. Oops. Let's go with white. If we were to do this, the constants, the ambient color, the light color, and the light direction. What? Oh, because it's not set. Okay. I was already panicking here. Okay. Why is everything red? Now I'm puzzled. Okay, something was wrong then. Never things go the way you want them to go. That's part of the fun. Okay, so this is obviously wrong. Fantastic. I know for a fact that there is something wrong. Oh my. So I'm afraid there is something wrong with the no. This is the identity matrix. Oh boy. Oh boy. Oh boy, what's happening? Oh boy. I am puzzled. I am. Something is not right. I'm sending the wrong data. I'm sending the wrong data. Yeah. I'm sending the wrong data, but I don't know where. What's the problem? Am I doing things like the stupid way? It cannot be. It cannot be this. It cannot be this. Come on. Yes, okay. I've restored the faith in humanity. So, launch it. Yes. What? Launch it. Sorry, no. Capture. The pixel shader, boom. Okay. Okay, so something is not right. And so dynamic buffer, lighting. Yes, the copy paste, the copy paste. The copy paste. The copy paste, bro, it's retarded. Never copy paste. Lol. That's the thing that was trolling me all along. Oh my god, yes, we did it. It's actually right now. Okay, that's what I was expecting. Don't save the capture. Let me see. Lighting, the ambient color, fantastic. The light color, what? Stay here, fantastic. The lighting direction, this is beautiful. And here is the pad. Okay, I can forget about it here and here. Yeah, I should find a hack for you. Yeah. So now, run it. Everything's good. Everything is good, no errors on the log. Okay, the debug output. Launch. Booyah. No mesh viewer. Lighting. Yes. Okay, so cool. Everything. sorry. So the idea is that okay, so this is the ambient component, this is the ambient thingy, so you can't see shit basically, and then we need so float for ambient float for so ambient component the directional would be in order to compute the directional component we need to basically get the so first and foremost for 3 float 3 the directional component. What do we need? Well, basically we need the position. We have the position, we have the normal. Okay, so float 3 the word so this is the word we need the word position as vertex output. So the default not very efficient. So float for So we need the world position. This is the position. So why not do this? Oh, because look, so world position float for world position dot zero. Come on. I put that world position. This is our world position. I put that position dot attack. I put that normal. We take the model. The normal. So constant buffer object the model, constant buffer the normal. The world position, I multiply the model matrix by the input position as a point, and then take the XYZ, and then we take the world position as a point, multiply it by the view, and the result multiplied by the projection, and this is our position. The normal, we take the normal matrix, we multiply the position, input of position. What? The normal, dude. Like the normal, I don't know what I wrote. Normal, take the object, take the normal matrix, multiply it by your normal, take the XYZ as a point, not as a point, your normals, the normal is not a point, your normal is not a point. It's a direction. XYZ, output UV, input UV, fantastic. When I'm here in the renderer, when I position, rotation, scaling, mesh, no, yes, scale, rotate, these are 3x3 matrices, so they don't transpose, whatever. Normal dot invert, transpose, so the transpose of the inverse of your scaling and rotation. Obviously you don't need any sort of translation. Fantastic. This was correct. World position, if I do this, what? If I do this, what? How? Oh yeah, because the vertex input is the same. Vertex input is the same as the vertex output that changed. Okay. So now the idea is that we want with delete, we have the vertex output, of the position, the world position. So we have the input dot world position. Okay. So the light direction would be from the source to our point. What we want is the inverse of the light direction, so it's the opposite of the light direction. So it's from the point to our light. So basically we need two vectors. A vector from the point to the light, which is no. A vector. We don't need the world position. Yeah. I'm too tired. I think we don't need the world position. No, because we have a light direction. Okay, we want the normal, so we need a light direction. We have the normal, and we need to compute the angle between the direction and the normal at a point. Okay, so we need to compute the angle between the normal and the direction. Actually, the direction should not be like direction and like this from the light to the point, but should be from the point to the light. So basically the opposite direction, so that we have something like this, like normal and like the negated light direction. Then we can compute the angle of these two vectors, and the magic thing is that the more the light is perpendicular, the more the light, our inverse light direction gets closer to the normal, the higher should be, like the higher the light shines on the surface. The further, oops, this is the normal. This is the normal. The further the light direction deviates from the normal till reaching a 90 degrees or sub 90 degrees, like the less the light shines on the surface. When it goes past 90 degrees, well, the light should like come from inside the surface, so it doesn't make sense, so it's zero, the amount of light that actually shines on the surface. So what we need, is not, this is my error, is not the world position, absolutely not. We just need the position and the normal. The default vertex shader does the world position, so we can just oops. So we can just take this. Okay, the normal is this. Okay, now we have like we need the dot product. Okay, so basically to measure the angle, so sorry, first and foremost we need to normalize the normal, because it could due to like numerical instabilities, I think it may not actually be normals. Okay, like unit length vectors. So our normal is input HLSL normalize. Fantastic. Normalize input dot normal. Okay. Then we have something like the like direction, same thing, normalize what, constant buffer dot like direction, yes, it's a float 4, so like direction, sorry, XYZ. Then we have the light direction, so float is the coefficient k, which is the dot product between the normal and the negated light direction. Now, this may be negative, of course, in scenarios like this, okay, higher than 90 degrees. The idea is that we take the max between this, so between 0 and this. Whoops. When this is negative, the max will be 0. Okay. When this is obviously higher than 0, the max can be 0. And then the directional would be k times what? Constant buffer lighting dot the light color dot XYZ. I should probably do something better, like normal, normalize, light direction, blah blah blah, float, blah 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 blah. So this is the directional light. So we compute our directional component. We take the ambient color. We take the directional light color, the directional component computed by the k. So how much this dot, since both of them are normalized, this thing right here will be like something between -1 and 1. Doing this, capping it to 0 means that this will be from 0 to 1, so it's basically a percentage of it's how much does our light shine on this point. And based on this, we know how much, like, we know how much color light color is on this point. Okay, so we take the ambient and we add it with the directional, and we're done. Now if we rotate, you can clearly see that remember, whoops, the light direction, we have X, Y and Z, X, Y and Z, and this is minus, minus, minus. So it's basically something like that. Okay. Our camera the position is from 10 10 10. Okay, so the light goes like this, the light goes like this, our camera is here. Okay, so the light goes like this, our camera, so basically the light goes, so X, Y, Z means that our camera is here. The light direction is something that goes like this, basically. So it's the same as the direction from the camera to the target, to the origin, okay? So it makes sense that the light shines here, okay? So it makes sense that this is illuminated, when we rotate, this is shaded, okay? Fantastic. Obviously this looks flat because there is no interesting topology here. The light shines uniformly, since it's directional light, on all the surfaces. So like uniformly on the plane, okay? So yeah, that's it. Very basic, like just this basic technique, okay, of ambient plus directional lighting actually makes things, makes the scene, makes the objects way more interesting. In what? Like this amount of code. Like the tricky part is uploading data to the GPU, and we took our time to think about it, because like I implemented it, like I haven't read anything about it in weeks, and I mean I needed to think about it, okay, better think about it, and we also like lost a lot of time with due to like having uploading, or better, setting the wrong buffer, like due to a copy paste error. Fantastic. So it works. It's not very clean as of right now, but we'll clean it like later meaning the next time, like to do. And this is starting to get annoying, so because I have to remember to change 2 places. So maybe we'll do the stupid thing. Okay, so implement ambient plus directional lighting. fantastic. Then I would like to check whether or not everything is cool. So I should like visualize the normals. I should I should try to change these settings, so the ambient lighting, the direction of the directional light, using IMG UI, like things that should be done, that will be done next, like in the following streams. I mean, okay, it's good, solid 2 hours stream, beautiful. Bye bye.